For the set A containing the elements A and B, list all relations on A and find the total possible relations. Okay, let us begin. So first what we'll do, we are going to note down the set. We have the set A containing the elements A and B. So that means there are a total of 2 elements, so a number of elements in the set A that's equals to 2. So our goal will be to list out all relations on A. What does it mean when we say all relations in A? This simply means that we have to find a relation R such that that is a subset of the Cartesian product of A with itself. Okay, so how many such relations are possible such that they are subset of the Cartesian product of A and A? Now let's do one thing. Let's try to find out the Cartesian product of A with itself. Cartesian product of A itself means we have the set A containing the elements A comma B. We're going to take its Cartesian product with that same set A containing the same elements A and B. That's going to give us the Cartesian product of some ordered pairs. To find out the ordered pairs, we first consider the first element of the set A, that means the first set A, and form an ordered pair with the two elements of the other set A. So we have A comma A and A comma B. That's going to give us the two ordered pairs. Next, we're going to pick up that second element from the first set A and form an ordered pair with each of the two elements of the second set, that is B, A itself. So we have B comma A and B comma B. So here we have obtained a total of 4 sets. Okay, so this is the Cartesian product of the set A with itself. Now the question is, what is the total relations? Not relations, well, what is the total subsets? What will be the total subsets of the Cartesian product of A with itself? Now, to find it, what we need is, we need the total number of the elements in the Cartesian product of the set A with itself. So here we simply see that's 1, 2, 3, 4. There are a total of 4. Also, that can be obtained by simply taking the product of the total number of elements in A with the total number of elements in A itself. So 2 times 2, that gives us 4. Total number of subsets will be given by 2 raised to the power of 4. So that's going to be equals to 16. So that means there are 16 subsets of the Cartesian product of A and A. Now, however, our goal is to not find out the total subset but the total possible relation, which incidentally is also the total relations of possible relations of A and A. So the total possible relations on A is simply equals to 16. There are 16 such relations possible. So we need to list out all the relations. Listing out all the relations means first what we'll find out the total subsets of A and A. So here, since we have mentioned that there are a total of 16 subsets of A and A, so what are the subsets? We'll have the null set, then we have the set containing a single ordered pair A comma A, then we have the set containing the ordered pair B comma A. Next, we have the set containing the ordered pair A comma B. We have the ordered pair B comma B. We have each of the set contains one ordered pair. Next, we're going to take 2 ordered pairs at a time. So we have A comma A and we have A comma B. Next, we can take the set containing the elements A comma A, and then we have the elements B comma A. We'll take another set containing the elements A comma A and B comma B. Fine. Next, we have the set containing the elements A comma B, and then we have B comma A. Then we have A comma B followed by B comma B. And then we're going to take these 2 ordered pairs. We have the set containing the elements B comma A, and we have the set containing the elements B comma B. Next, we're going to take 3 ordered pairs at a time. So we can pick up the first 3 ordered pairs, set containing the ordered pairs A comma A, then we have A comma B, and next we have B comma A. Okay. Next, we can pick up the first ordered pair, the third ordered pair B comma A, and the fourth ordered pair B comma B. Then we're going to consider another set containing the second ordered pair A comma B, the third ordered pair B comma A, and the fourth ordered pair B comma B. Fine. Now we'll take one big set containing all the ordered pairs. So we have A comma A, A comma A, then we have A comma B, next we have B comma A, and then we have B comma B. So let's count. We need a total of 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have obtained 16 subsets of the Cartesian product of A and A, and each of them are going to be the possible relations. So let's name them. So we can have R1. So let's say R1 is the empty relation given by phi. Then we can R to be the set containing the ordered pair A comma A. Now clearly A comma A, we can see here that this is a subset of the Cartesian product of A and A. So likewise, we can define all the rest of the relations. So there will be a total of 16 relations.